So the rectangular lawn is 38 meters by 25 meters. Now this is surrounded externally. That means on the outside. On the outside, runs another rectangle, creating a path. Creating a path here. This is the path. This is the path. Now the dimensions of the lawn, 38 meters by 25 meters. And the width of the path, the uniform width of the path is 2.5 meters. So that means it's 2.5 meters here, 2.5 meters here, 2.5 meters here, and 2.5 meters here. The rectangular lawn is surrounded by a path 2.5 meters wide on the outside. So now this makes two rectangles, one inner rectangle and one outer rectangle. Because there's a path, you can see two rectangles, one inner rectangle and one outer rectangle. The dimensions of the inner rectangle are given to us. The dimensions of the inner rectangle are given to us, 38 and 25. So using this, we'll have to find the dimensions of the outer rectangle. So the dimensions, the length of the outer rectangle will be 38 plus 2.5 plus 2.5. 38 plus 2.5 plus 2.5 will be the length of the outer rectangle. And the breadth of the outer rectangle will be 25 plus 2.5 plus 2.5. Correct? Yes or no, children?
Yeah,
this one is, this one is 38. This is 2.5 meters wide on either sides. So 38 plus 2.5 plus 2.5 will be the outer length. The outer breadth will be 25 plus 2.5 plus 2.5. So like that, we calculate the external length and the external breadth. So the area between the two rectangles is the area of the path. The area of the path is the area between the two rectangles. So the area between the two rectangles is the area of the outer rectangle minus the area of the inner rectangle. So rectangle area we know L into B. So area of the outer rectangle, capital L into capital B. Inner rectangle, small l into small b. The difference between these two areas will be the area of the path. Now, to gravel 1 meter square of this path, the rate is 120 rupees. So for 1 meter square, 120 rupees. Then for 340 meters square, how much? 340 into 120. It's given very clearly that the lawn is surrounded by a path. The path runs all around the rectangular lawn outside it, externally. That's important. So we are given the length of this rectangle, length and breadth of this rectangle. We need to find the length and breadth of this rectangle, which runs on the outside. Okay. Yeah. Got that, children? All of you finish this one? Okay.
Yes, ma'am.
Yeah, take down the next question. Question number 2.
Ma'am, I wasn't done on the question, ma'am.
Okay, I'll read it out for you. Find the area of a rectangular plot, one side of which is 48 meters.
Okay, ma'am.
And its diagonal 50 meters. And its diagonal 50 meters.
Okay, ma'am.
Yeah. So here we are given the length of find the area of a rectangular plot, one side of which. So any side, you can take the length or the breadth as 48 because it's given one side. Okay, one side is 48. So you can see I've taken AB as 48 and the diagonal BD is 50. So you can find AD using Pythagoras theorem. So once you find AD using Pythagoras theorem, L into B will give you the area of the rectangle. Yeah, work this. We are given one side of the rectangle and one diagonal of the rectangle. But to find area, we need length and breadth. So we use a right triangle ABD to find AD, which is the breadth. And then L into B will give us the area. Done, children?
Just almost done, ma'am.
Okay. Done, children?
Yes, ma'am.
Okay. Yes. Yeah. And how did you find the square root of 196? Square root of 196? You should either use the long division method or the prime factorization method. 196, 2, 98 times 2, 49 times 7, 7 7 1. So from 2 2s, 1 2 out, from 2 7s, 1 7 out. So 7 2s are 14. The square root of 196 is 14. If it is cube root from 3 equal factors, we bring 1 out. So cube root. The square root from 2 equal factors, 1 out. So from 2 2s, 1 2 out. From 2 7s, 1 7 out. 7 2s are 14. It's the square root of 196. Okay. So in this question, we have to find the area of the rectangle for which we need the length and breadth. But we are given length and diagonal. So we need to find the breadth using Pythagoras theorem. And then find the area using the formula ln to b. Yeah, take the next question. So how do we assume the length of the rectangle? Let the length be. Sorry. Let the length be
X.
x. No. 5.
5x.
5x. Let the length of the rectangular field be 5x meters. And let the breadth be 3x meters.
3x.
Very good. Yeah, what is the formula to find the perimeter of a rectangle?
2 into L plus B.
2 into L.
Yeah, 2 into L plus B. So what is 2 into L plus B? 2 into L plus B is equal to 480.
480 meters.
2 into L plus B is equal to 480. So 2 into 5x plus 3x is equal to 480, correct? Yeah.
Yeah,
So we
ma'am.
need to work that and find the value of x, then find the length and breadth, and hence find the area. Yeah. So 5x plus 3x is 8x, not 8x squared. 8x.
Done, ma'am.
Very good. Anybody still working? Okay. Next question. The fourth one. A rectangular sheet of acrylic is 34 centimeters by 24 centimeters. So there's a rectangular sheet of acrylic. It's a material. The length of which is 34 centimeters and breadth 24 centimeters. From it, that is from this rectangular sheet, 64 circular buttons, each of diameter 3.5 centimeters, have been cut out. So from this rectangular sheet, 64 circular buttons, each of diameter 3.5 centimeters, have been cut out. Find the area of the remaining sheet. So try to tell me in words, how will we find the area of the remaining sheet? What are the steps? So we have to first, step one is to find the area of the rectangular sheet. What is the actual area of the rectangular sheet? 34 into 24. Next, find the area of one circular button, pi r square. Area of a circle is pi r square. Diameter is 3.5. So radius will be 3.5 by 2. Radius will be 3.5 by 2. Diameter 3.5, radius is 3.5 by 2. So you can take this 1.75 or you can take this fraction also. I'll tell you that later. So diameter is 3.5, so radius is 3.5 by 2. Area of one circle is pi r square. So find the area of one circle and multiply that with, answer with 64 to find the area of 64 circles. Now the area of the rectangular sheet minus the area of the 64 circular buttons will be the area of the remaining sheet. Area of the rectangular sheet minus the area of the 64 circles. Area of one circle is pi r square. 64 circles will be that answer into 64.
Ma'am, I need the question, ma'am.
I'll read it out for you. I've also shared from WhatsApp. Is it, can you find it on WhatsApp? Do you have a phone with you?
Right.
Okay.
I'm using a phone, right?
Yeah. Otherwise, I can read the question for you. Yeah. You can see the paper on WhatsApp. So how do you convert 3.5 by 2 to a fraction? 3.5 by 2, shift the decimal point, meaning multiply the numerator and denominator by 10. So 3.5 into 10 is 35, 2 into 10 is 20. See, how do we convert? We have 3.5 by 2, right? 3.5 is the diameter, by 2 is the radius. Now you don't want this decimal point. How will you shift it? So do this in your mind. Multiply 3.5 by 10 and 2 by 10. This you do it in your mind. So what will you get? 3.5 into 10 is 35. 2 into 10 is 20. Diameter is 3.5. So radius is by 2. Now we don't want this decimal point. So we multiply the numerator and denominator by 10. Now 3.5 into 10 is 35. 2 into 10 is 20. That's what you see in the next step. 35 by 20. You don't have to show that step. Multiplying and dividing by 10, that step you don't have to show. Just do it in your mind. Yeah. Please cancel and see to that, calculate and see that you're getting 616. Don't just write it because you can see the answer in front of you. Please be responsible. Area of a circle is pi r squared. So 64 circular buttons, 64 into pi r squared. Pi r squared is a formula to find the area of one circle, a circle, into 64 for 64 circles. You need to cancel, children. So it's like 7 ones are 7 fives are, 5 ones are 5 fours are. Then 4 ones are 4 16 times. Then 4 fours are 16, 4 fives are 20. And then 5 ones are 5 sevens are. So in the numerator, we have 4, 22, and 7. 4, 22, and 7. So it's 88 into 7. 7 is a 56, 5 carried over. Yeah, see? So you need to simplify this, children. Simply don't write 616. Do the simplification your own way. You can do 5 sevens are 5 fours are, 5 sevens are 5 fours are, 4 ones are 4 16 times, 4 ones are 4 fours are, 7 and 7 cancels. So please simplify. Yeah, any question here? So if I don't get any response, I'll just assume that you finished and go to the next one, children.
Understood, ma'am.
All right, thank you. Next one. So you can see the figure there in 5A. Find the area of the shaded region. That's the question. So I want you to do this for yourself. Find the area of the rectangle ABCD. That's the first step. Listen to me. Find the area of the rectangle ABCD. Okay. And then find the area of this triangle FDE. And the area of the triangle BCE. Yeah. Find the area of the rectangle. Find the area of the rectangle. Then find the area of this triangle and this triangle and add the areas of these two triangles. Add the areas of these two triangles. Find the area of this triangle and this triangle and find the sum of the areas of these two triangles. Now from the area of the rectangle, if you take away this sum, you will be left with the area of the shaded region. Do this. First find area of rectangle ABCD. Then find area of triangle DEF. Then find area of triangle BCE. Add these two and subtract from ABCD. I'm sorry. Oh. Yeah. Yeah, children, what's the area of the rectangle ABCD?
180 centimeters square, ma'am.
180. Very good. 180. What is the area of the triangle DEF?
30 centimeters square.
Correct. Area of triangle BCE?
Still working on it, ma'am.
Okay.
Is it 40 centimeters square?
Correct. Yeah, present is the answer.
Got the answer right, ma'am.
Very good. Very good, Gayatri. So the total area of the unshaded region. The two triangles are not shaded. So that is 30 plus 40, 70. So the area of the shaded region will be the area of the whole thing, that is a rectangle, minus the area of the unshaded region. Done this, all of you?
Yes, ma'am.
Okay.
Yes.
Okay. Good, Yarni. Next one, 5B. Find the total area of the shaded regions. See the question, children. Find the total area of the shaded regions. So what is the length of this line segment AB?
40 centimeter, ma'am.
40.
Sorry,
Yeah, what is 40 minus 2?
38.
38. So 38 by 2, 38 divided by 2. 19. So that means this is 19, this is 19, this one is 19, and this gap, this is 2, correct? So the length of these two rectangles is 19 meters. Now come to this side. How much? 40. 40 minus 3, 37. Yeah, 37 by 2. You will get these portions. So then you should find the area of the 4 regions. It's as simple as that, Havini. The area of the total region, the shaded regions will be 4 into, because all the rectangles will have the same length and breadth. All the rectangles will have the same length and breadth. So 4 into area of region 1. 4 times area of region 1, area of the total shaded regions. You can see the answer completed right on top there. Finish this.
Completed this page, ma'am.
Yeah.
Done, ma'am.
Yeah. Next question, the 6th one. Find the area of the square, the length of whose diagonal is 72 centimeters. Find the area of a square, the length of whose diagonal is 72 centimeters. So ABCD is a square with side A units. You can see the diagonal BD is 72. So use Pythagoras theorem. A square plus A square is equal to 72 square. Because AB square plus AD square is equal to BD square. Because this one is a right triangle. So in the right triangle, AD square plus AB square is equal to BD square. Pythagoras theorem. So AD square is A square. AD is A. So AD square, A square. AB is also A. So AB square is again A square. Is equal to BD square, 72 square. So on working this, we get A square is 2592. You can stop there because the question is to find the area of the square. And what is the formula to find the area of a square? A square. So A square means area. For a square, if A square is given, that means area is given. So here we get 2A square is equal to 5184. A square is equal to 5184 by 2. A square will be 5184 divided by 2. So 2592. What is A square? A into A, which is the formula to find the area of a square. So A square is 2592, meaning the area of the square is 2592 centimeters square. Yeah, the seventh one. The area of a square is 16200 meters square. Find the length of its diagonal. What is the formula to find the length of the diagonal of a square? Root 2a. Root 2a. Or you can also use Pythagoras theorem. Okay. So area of the square is given 16,200. You can see we have represented the information with the diagram. PQ, we have taken PQRS, square PQRS with side A units. So area 16,200 meters square is given. That means A square. Area of a square meaning A square is given. A square is 16,200, not A. A is the side of the square. A is the side of the square. We are given area. That means A square we are given 16,200. Okay. Now connect one of the diagonals. So here we have connected PR. Use Pythagoras theorem. PQ square plus QR square is equal to PR square because PR is a hypotenuse. So have that alone on one side and square and add the remaining two sides. PQ square plus QR square. So PQ is nothing but A. PQ square, A square. QR is also A. QR square is A square. But we know A square is 16,200. So substitute. A square is 16,200 is equal to PR square. So we get PR square is equal to 32,400. PR is equal to square root of 32,400. So PR is equal to 180 meters. So PR meaning the length of the diagonal is 180 meters. Again, you'll have to use the prime factorization method to find the square root of 32,400. You don't have to find the square root of 32,400. You just have to find for 324. Because if a square number has two zeros in the end, its square root will have 1 0 in the end. If a square number ends with two zeros, then its square root will end with 1 0. So just find the square root of 324. 2, 2, so from 2 to 1 2, from 2 3 is 1 3, and from 3. 3 3s are 9, 9 2s are 18. 18. The square root of 324 is 18. Then the square root of 32,400 will be 18. The number has two zeros. Its square root will have only 1 0 in there. So 180. So you don't have to find the square root of 32,400. Just find for 324. Find the square root of 324 by the prime factorization method. And the number ends with two zeros. So its square root will have half the number of zeros. If the number ends with 6 zeros, then the square root will have 6 by 2, 3 zeros in the end. Okay, so 180. So the length of the diagonal of the square is 180 meters. So here the area is given. That means A square is given. A square is 16,200. When we apply Pythagoras theorem, P by TH means Pythagoras theorem. In right triangle PQR by P by TH meaning Pythagoras theorem. P by is Pythagoras, TH is theorem. So there you will get A square plus A square. A square is 16,200. Okay. Find the radius of a circle whose circumference is 57.2 meters. Radius of a circle whose circumference is 57.2. What is the formula to find the area of a circle, children? Area of circle is given by the formula
Pi r square.
pi r square. Pi r square square units. And what about the circumference of a circle? Formula?
2 pi r.
2 pi r. 2 pi r.
pi
So
r.
here what is, yeah, very good. Here what is given? Is pi r square given or 2 pi r given? Two pi r is given. 2 pi r is given. 2 pi r is equal to 57.2. Correct. So how do we start working? Circumference is given. Circumference is 57.2. That means 2 pi r is equal to 57.2. So you should work that and find the value of r. Yeah. After this, you complete. I'm not taking you to the next slide. Circumference is 57.2. So 2 pi r is equal to, shift the decimal point. So 572 by 10. Yeah, find the value of r. Yeah, find r. Tell me, children, what's the value of r? Yeah, what's the value of r?
I'm getting 179.77, ma'am.
Okay, let's see. So r is equal to what? 2 and 22 by 7 will come to the other side, right? We'll have to transpose them. 2 will become 1 by 2. It will become its reciprocal on the other side. And 22 by 7 will become 7 by 22 on the other side. You have to find r. To find r, you need to take 2 and 22 by 7 to the other side. So they become their reciprocals. 2 by 1 becomes 1 by 2. 22 by 7 becomes 7 by 22. Then simplify. You can simplify 572 and 22 in the tables of 11. In fact, directly you can do in the tables of 22, but you can do 11 first. 11 twos are 22 and 11 are 52 times. And then again in the tables of 2. So on simplifying, you get 13 into 7 by 10, 91 by 10, which is 9.1. The radius is 9.1. Shreya, how did you get such a big value?
I didn't transpose it, ma'am. I just multiplied it with it. That's the problem.
Okay. Yeah, do this, children.
Ma'am,
Yeah. Yes, Lakshana.
ma'am, I just joined right now.
Okay. You just joined, is it?
Yes, ma'am.
Okay. How can I help you?
Ma'am, could you tell me what have you done till now?
Yeah, we have completed 8 sums. We've just, I think I've shared the images on WhatsApp. The question images I've shared on WhatsApp. So among, out of those questions, we have completed the first 8 and we're about to start the 9th one.
Okay.
I can do one thing. I can share the answer images also. At the end of the class, I can share the answer images. I think that will help you. All right?
Yes.
Yeah.
Done, ma'am.
Yeah. So 2 pi r is equal to 57.2. You'll have to shift 2 and you'll have to transpose 2 and 22/7 to the other side. So they become 1/2 and 7/22. And on cancelling, you get 91/10, which is 9.1. So the radius of the circle is 9.1 meters. Yeah. Lakshana, take on the 9th question. We finished 1 to 8. Take on the 9th question.
Yes.
Yeah. Okay. So a racetrack is in the form of a circular ring, which means it's like this. The racetrack is like this. Okay, so this is the area where the participants will be using. Okay, so this is the ring. This is the ring. This is the ring, and this is where the the competitions, whatever will take place, the athletes would be using this area. So here probably the coaches and other people will be stationed here. People who are watching the athletes perform, they'll be here. So nothing happens in this portion. So this is the ring, this is the race track. This is the track. Okay. This ring is the track, the race track. Now the inner circumference, that means the circumference of the inner circle. Inner circumference meaning the circumference of the inner circle. This one is 528. That means 2 pi small r is equal to 528. So from this you can find the value of small r. And then the outer circumference. The outer circumference is the circumference of the outer circle, this circle. The outer circumference, this one, 2 pi capital R. Circumference, no, so 2 pi R. Outer circumference, so 2 pi capital R is equal to 616. So from this you can find the value of capital R. Width of the track is equal to capital R minus small r. Yeah, do this, children. I'm not showing you the answer slide. Please do this. Find the values of the two r's, and their difference will be the width of the track.
I found the answer, ma'am.
Yeah, children, the values of small r and capital R. Still finding.
Mom, for capital R, I got it as 98, and for small r, I got it as 84.
Correct. Yeah. Outer circumference is 616. So 2 pi capital R, 616. 2 into 22 by 7 into capital R is 616. So R is equal to 616. 2 comes to the other side as 1 by 2. 22 by 7 becomes 7 by 22. Correct, Lakshana? So R is 98. In the same way, when you work inner circumference, small r is 84. And the width is 98 minus 84, 14 meters. Got that? Yeah, any questions, students?
Done, ma'am. Questions,
Okay.
ma'am.
All right. Sure, all of you understood? Surya, Yarni, online students, use the emoji, raise your hand. Okay, Gayatri, Shreya, Anantika, Saujanya, Adistris, and Lakshana. Okay, good. All right, children, very good. Over to the next one. Yeah. The next question is the 10th one. The area of the circle. The area of a circle is 1,386 meters square. Find its circumference. We'll try all these three questions and then we'll see the answers together. Work out the answers to questions 10, 11, and 12. 10, 11, and 12. We'll see the answers together. Area is given. Pi r square is equal to 1386. So using that, you should find r. Work pi r square is equal to 1386. Work that and find the value of r. And then find the circumference using the formula 2 pi r. Yeah. Please share the answer for the 10th one. What is the radius of the circle?
441, ma'am. 441.
No, you're saying R square or R?
Oh, yes, ma'am. Yes, yes, yes.
Nobody has the answer for the value of R?
What's the value of R21?
Yeah.
What's the value of R21?
21. Correct. Was that Saujanya?
Yes, ma'am.
Very good. Yeah. R is 21. And what is the circumference of the circle?
132, ma'am. 132 meters.
Okay. Yeah, you can see it right below. Oh, sorry. This is which one? Oh, okay. Yeah, you can see it below. 22 pi r square. Pi r square is equal to 1386. So 22 by 7 into r square is 1386. Area is 1386. Pi r square is 1386. So 22 by 7 into r square is 1386. So you need to transpose 22 by 7. So it becomes 7 by 22 on the other side. So r square is equal to 1386 into 7 by 22. Upon simplifying, we get 441. R square is 441. R is the square root of 441, which is 21. So you can find the square root of 441 using the prime factorization method or the long division method. Now circumference is 2 pi r, which is 132. Okay, in question number 11, we have to find the distance moved by what's that? Okay, the distance covered by a wheel in going 2000 rotations. Okay, we need to find the distance covered by the wheel in going 2000 rotations. So the distance covered in one rotation is 2 pi r. The distance covered in one rotation is 2 pi r. So the distance covered in 2000 rotations will be whatever is 2 pi r into 2000. Circumference into 2000. But since d is given, you can also use the formula pi d. Circumference is 2 pi r or pi d. Circumference formula is 2 pi r, or we know that 2r is d, right? 2r, twice radius is diameter. So circumference is also pi d. 2 into pi into r. So pi into 2 times r is d. So pi d. So for circumference, you can use the formula 2 pi r. Then you should substitute the value of r, or you can use the formula c is equal to pi d. Take the value of d here. So since diameter is given, I found the circumference is using pi d. And then that's a distance covered in one rotation. So in 2000 rotations into 2000. The answer will be in centimeter. I converted that to meters. And then I converted that to kilometers. You can also directly convert it to kilometers. See, the thing is, we converted to meters, but you see it is 6,160 meters, which is more than 1,000 meters, because 1,000 meters is 1 kilometer. It's more than 1,000 meters. So you can further convert it to kilometers. So to find the distance covered in 2000 rotations, you have to first find the distance covered in one rotation. The distance covered in one rotation is equal to 2 pi r, the circumference of the wheel. Since diameter is given, I've used the formula pi d. So pi d is a circumference, 308 centimeters, and that is the distance covered in one rotation. So in 2000 rotations, it would be 308 into 2000. The answer is in centimeter because the diameter is given in centimeters. You see that it's a huge value for centimeters. So convert that to meters by dividing by 100. Still, it is more than 1,000 meters because we know that 1,000 meters is 1 kilometer. It's more than 1,000 meters. So you can further convert it to kilometers. So divide by 1,000. Meter to kilometer, divide by 1,000. So 6.16 kilometers. Shift the decimal point, that's all. Take the 12th question. Yeah, we'll see the answer with the 12th one. A radius is given. See, whenever it is about revolutions, you have to find the circumference of the wheel. Whenever it's about revolutions, you will have to find the circumference of the wheel. Now, number of revolutions, we have a formula. Number of revolutions is equal to the total distance by the distance covered in one revolution. The distance covered in one revolution is equal to the circumference of the wheel. And the total distance is 33 kilometers, but you need to convert that to centimeter. Yeah, see here. First find the circumference, children. You can see right below. You can see it right below. First find the circumference of the wheel. 2 pi r. R is given to you. Find 2 pi r. So that's the circumference of the wheel. And that is the distance covered in one revolution. When the wheel makes one complete rotation or revolution, in social studies or science, rotation revolution makes a lot of difference. You cannot use the terms interchangeably in social studies, science, geography, whatever. But in mathematics, it's fine. Rotation revolution is fine in mathematics, so it's okay. Yeah. So circumference of the wheel is 220 centimeters, and that is the distance covered by the wheel in making one revolution or one rotation. One turn, the wheel will cover 220 centimeters. In going one complete turn, the wheel will cover 220 centimeters. You should not find area, find the circumference. Now, so this is the distance covered in one rotation. What is the distance given? 33 kilometers. I said convert that to centimeters. Convert that to centimeters. Then, okay, I've used a proportion here. You can also do it like this. So in the proportion is an argument. Okay, so here I've worked it like this. I'll tell you the other way also. So 220 centimeters is covered in one revolution. Then so much centimeter is covered in X revolutions. This is a proportion. 220 centimeters, if the distance is 220 centimeters, that is covered in one revolution. If the distance is 33 followed by 50 centimeters, then what is the number of revolutions? See, the first term is distance, second one revolution. Again, distance, revolution. So you know that product of means is equal to product of extremes. So extremes, 220 into x, product of extremes, 220 into x is equal to product of means, 1 into 33 followed by 5 zeros. So x is equal to, you know how to solve this, and x is 15,000. So the wheel has to go 15,000 rotations to cover that distance of 33 kilometers. You can also find number of revolutions. Number of revolutions is equal to total distance by distance covered in one revolution. The total distance is 33, 1, 2, 1, 2, 1 divided by number of revolutions, 220. You can also do it like this. You can also take this formula. Number of revolutions is equal to total distance by distance covered in one revolution. Total distance is 33 kilometers. Convert that to centimeters. By the distance covered in one revolution, which is a circumference, 220. Okay, so you can see the answer right below 12th one. First, find the circumference of the wheel, 2 pi r, which is 220 centimeters. Then distance is given, but convert that to centimeters. And then you can use the formula. Number of revolutions is equal to total distance by distance covered in one revolution. Or you can use the proportion. Okay, so find the area of this figure. Find area and perimeter, children. Find area and perimeter. And perimeter of this figure. Okay. This is a rectangle, children, and this is a semicircle on it. Okay, this one is a rectangle. And on that you see a semicircle. 14 centimeters, and this one is 10 centimeters. Yeah. Find the area and perimeter of the figure. So what's the diameter of the semicircle? How much is the diameter of the semicircle?
14 centimeters.
14 centimeters. Then what is the radius?
7 centimeters.
7 centimeters. Very good. What's the formula to find the area of a circle? Pi r square. Then how do you find the area of a semicircle?
Pi r square by 2.
Yeah. Yeah, half into pi r square. Half pi r square by 2 or half into pi r square. So this figure has a rectangle and a semicircle. Find the area of the rectangle, L into B. Then find the area of the semicircle, half into pi r square. Pi r square is for a circle, semicircle, half into pi r square. R is 7 because diameter is 14, so R is 7. Do that and find the area. Area of rectangle is equal to L into D, 14 into 10, 140 centimeters square. Area of circle. Oh, sorry, semicircle. Area of semicircle. Is half into pi r square. So half into pi is 22/7 into r square. Diameter is 14, so 7 into 7. 7 and 7 cancels. 2 ones are 2 11 times. So 77 centimeters square. So the area of the figure is equal to 140 plus 77. 217 centimeters square. Correct?
Yes, ma'am.
Yeah. Now tell me the perimeter, children. What's the perimeter?
Ma'am, I got it as 56.
56. Lakshana, is it?
Yes, ma'am.
56. Okay, tell me what are the line segments or curves you've added?
Ma'am, first I've added pi r.
Perimeter of the figure is equal to, yeah, tell me.
Pi r plus length plus breadth plus breadth.
Very good. Very good. So perimeter is just the length of the boundary. So walk along the boundary of this figure. So say you start from here. You walk like this. You cover 14 centimeters. Then you go like this, 10 centimeters. Then like this. This is pi r. And then you come back to the starting point like this, 10 centimeters. So when you go this way, 14 centimeters, 10 centimeters, and this one is pi r. The length of this semicircle is pi r, and this one is 10. This one is 10. 14 plus 10 plus pi r plus 10. 14 plus 10 plus pi r plus 10. It's just the length of the boundary. Because for a circle it is 2 pi r. Semicircle 2 pi r by 2 pi r. Length of the circle is 2 pi r. Semicircle 2 pi r by 2 pi r. So perimeter is 14 plus 10 plus pi r plus 10. So that will be 34 plus pi r. Pi r meaning 22/7 into r, which is 7. So 7 and 7 gets cancelled. 34 plus 22, 56. Did you say 56, Lakshana?
Yes, ma'am.
Yeah, good. You should not add the length of this line segment. This one is not considered because this is not in the boundary. This is running across the figure. It's inside the figure. This one will not be counted to find perimeter. Perimeter is only the length of the boundary. Yeah, if you've not finished, please take a screenshot. All right, children. Any questions? Anybody?
No, ma'am.
All right, children. So that's it for today's session. Thank you so much. You can leave the call. Good night.
Thank you, ma'am.
Thank you.
Thank you, children.